In this Algebra 1 video, we're going to be taking a look at how we would go ahead and evaluate exponential expressions. This is when we're actually going to be combining multiple variables and giving them many different values in order to solve our exponential expression. So in this first example, we're going to be taking a look at if we had within parentheses, we're going to be taking a look at if we had x plus y, and then we want to square that. We want to figure out how we can go ahead and solve this. Well, first of all, we're going to solve when x is equal to the first power, or when x is equal to 1, and when y is equal to 2. So what we have to do here is, first of all, substitute for our variables. We know x is equal to 1, and we're going to be adding that to whatever the value of y is, and that is 2. And of course, we have to bring down the power. So if we go ahead and we solve this out, we get 1 plus 2. Within here would be 3 because we're adding what's inside of the parentheses, and we also have to carry our power. And then of course we know that 3 times 3 is going to be equal to 9. So that is our first example. Now what I want to also do is take a look at what we would do if we had these two split up just like this. Let's say we had x to the second power, and we're going to be adding that right here to y to the second power as well. Let's change up our variables. We're going to be solving for when x is equal to 1. We'll keep that, but then we're going to be solving when y is equal to 3. So what we would have to do right here is, first of all, substitute in for our variables. That's pretty simple. We just simply bring down x is equal to 1, so we're going to be squaring 1 to the second power and do the same thing for y. We know that y is equal to 3, so then we also carry the second power. Now what we have to do is actually solve for each independent power and exponent before we can go ahead and add them, because what is different from this and this is that within the grouping right here, we know to do whatever the operation is within the parentheses before we take the exponent. But the problem is here they are separated. So an easy way to think of this, which might have been mentioned in Algebra 1, would be Pemdas. Pemdas. This stands for, first you solve for whatever is within the parentheses, then you solve for the exponent, whatever that might be, then you would go ahead and multiply, then you would divide if you have to, then if you need to add, and then if you needed to subtract. So when we go by Pemdas, we see that first we have to do what is inside of these parentheses, just like we do here before we square them, how we added here first. And now these are in their own parentheses, so again, there's no operation within here, so then we can cross out the p, and now we take the exponent. So this is going to be equal to 1 times 1, which we know is 1, and then 3 times 3, which we know is 9. So now we did the addition part, and that's going to be equal to 10. Let's get rid of this little line here so we can reference on our next example what we would go ahead and we would do. So let's keep the parentheses just like this. The next sort of example I want to take a look at would be if we had to furthermore solve within groups. So the two distinctions that we're going to be taking a look at would be, let's say we had the problem x to this, or x with 2x to the third power, and we also had 2x within parentheses to the third power. Now taking a look at these are actually two very different problems for a couple of reasons actually, which makes them two separate problems. So first of all, let's solve when x is equal to, we'll use 4 for this example. So in this problem, we have no parentheses. So if we go ahead and we plug in 2, and then we have to put whatever the value of x is, since we know to do exponents first, x is raised to the third power. So this is going to be its own separate exponent problem, because again, there's no parentheses, but then we see that we have to square x to the third power, and x happens to be equal to 4. So what this is really going to be is 2 times whatever this result is. So let's go ahead, let's actually group that off and let's write this out. This is going to be 2 times, within the parentheses, 4 times 4 times 4. This is going to furthermore be equal to 2. And 4 times 4 times 4 is actually going to be 64. And again, then 2 times 64 is going to come out to be 128. So what made this different from right here is that we, of course, had to square the exponent first. But now let's take a look at 2x to the third power. We have a parenthesis that came first, not an exponent. So what we're going to have to do is we're going to have to solve for whatever is inside of here first. So we know that the value of x is 4. So we plug that in. So first we have to multiply 2 times 4, just like we did on the inside right here, but we added up here. So that is going to come out to be 8. 2 times 4 is 8. And then we raise 8 to the third power. And so furthermore, this is 8 times 8 times 8. And we know 8 times 8 times 8 is going to come out to be 512. So it's important whenever you're solving for an exponent, or really almost any problem within algebra or any mathematics for that instance, to go by the rule of Pemdas: parentheses, exponents, multiply, divide, add, and then subtract. If you remember just simply Pemdas, you will always be able to solve for any exponent.